So as we're doing more trig, we're going to start doing some trig word problems now. We've seen a few little trig word problems, but we saw one problem a little earlier in the homework that mentioned things like angle of elevation and angle of depression. So let's review what those things are. Let's talk about that definitions before we move on. So angle of elevation, angle of depression has to do with how you see things. So let's say this line here is my line of sight. It's exactly where I'm seeing on a horizontal. Okay, so we call this the line of sight. And that line of sight is always horizontal. Now, as I look at the line of sight, I could look upwards or I could look down. Well, if I take my gaze and I look upwards, that's called an angle of elevation, is what I've created. So when I look in an upwards direction from the horizontal, this angle here, there's going upwards, is an angle of elevation. Because we're looking upwards that way, okay? If I were to look down on something, so I take my line of sight, which was horizontal, and look downward, now I'm creating a different line. I'm creating a line that's an angle of depression. Okay, so this angle going downward like that is an angle of depression. The key is to recognize that both of these angles are being taken from a horizontal line. Okay, so now that we've got that little bit of note of what an angle of depression is and an angle of elevation are, those two different things, let's look at how some of them work on some problems. Okay, so go to our worksheet. We're going to take a look at that. Let's go. So looking at this, let's define these two angles. An angle of elevation is an upwards angle from a horizontal line. Okay, so here's my horizontal line. The angle is upwards. So this angle 1 is an angle of elevation looking up to the airplane. Okay, so using that type of problem, we can now figure out some trig problem with it. Let's take a look at this problem. So Scott, whose eye level is 1.5 meters above the ground. So Scott is 1.5 meters tall. Okay, or at least his eye is. Okay, so he's looking this way. That's his eye height. And he stands 30 meters from a tree. So this is 30 meters here. The angle, we need to find the angle of elevation. Okay, so angle of elevation. He's looking upwards towards this bird. There we go. And since it's an angle of elevation, we're looking up from the horizontal line. We know that angle of elevation is 36 degrees. So there we go. How far is the bird? How far above the ground is the bird? So we need to know this height here. Okay, from up here all the way down. But you got to be careful with this problem because you can get real messed up in trying to figure out what the numbers are you're looking for. Because if you look at it, our triangle is only here. Okay, so we need to actually only find this part first. In fact, I'll call this, let me get a better color here. I'll call this B for bird. And that's what we want to find first. There's my right angle. This 30 meters is going to be here as well. So the 30 meters is my adjacent side. That's adjacent here. I'm looking for the opposite. So there's the adjacent. That is my opposite. So opposite over adjacent, if I go SOHCAHTOA, that's going to be my tangent. So the tangent of 36 degrees is my opposite over my adjacent. So I can cross multiply. And now I'm going to enter that into my calculator. Okay, so let me make sure my calculator's in degrees first of all. So tangent of sine of 30, is 1/2. Good, so I'm in degree mode. I know that for a fact. So 30 tangent of 36 degrees gives, let's get that into a decimal, why don't we? 21.7, so B equals 21.7963. Okay, now that's actually only B. That's not the height above the ground. That's this distance here. I have to add this other 1.5 to it. So I'm going to add that 1.5. And it did some really funky stuff here. Let's get this number as a decimal place. So my height is 23.2963 meters. Okay, now I'm going to actually round it. They didn't tell me what to round to, so I could leave it here and be okay. They did have 1 decimal point here, so I'm actually going to round to the same 1 decimal point and call it 23.3 meters. Okay, because they didn't tell me anything about that. Okay, so that's an angle of elevation. Remember that angle of elevation is from a horizontal upwards. Now we can take that and let's talk about angle of depression. Angle of depression, remember we said in our demonstration, was downward from a horizontal line. So when I talk about the angle of depression, I'm talking about, let's see that, put that on the next page. No, okay. So when I define angle of depression is a downward angle from a horizontal line. So always identify your horizontal line. That's how I like to start. There's my horizontal line, so go down, there's my angle. This doesn't work that way. This is not an angle of depression because my horizontal line is there, okay? So in this case, this one works. But a big mistake people tend to make is they keep thinking that this is their angle of depression, and that is wrong, okay? So be careful of that. You want to find that horizontal line first and then go down from there. Let's look at a quick example, and then we'll have you do some of your own. So, standing in the gallery of a lighthouse, the deck at the top of the lighthouse, a person spots a ship at an angle of depression of 20 degrees. So the guy sees the ship. He goes, hey, look, there's a ship. But it says right here, angle of depression is 20 degrees. So I need to set up a horizontal line this way. And there's my angle of depression, okay, 20 degrees. The lighthouse is 28 meters tall and sits 45 meters off on a cliff. So that's 45-meter cliff. What is the horizontal distance? That's important to know, the horizontal distance between the lighthouse and the ship. So if I create my triangle here, okay, well, let's see. I'm looking for horizontal distance, so that's what I'm looking for. This distance from the, we'll call that all the way down to the water, is going to be the sum of this. I can slide that over here. So the 28 and the 45 add together to make 73 meters. And now I've got my triangle. Some people don't like it drawn that way. Maybe they like the triangle to sit this way, so if you want to spin it around, that's fine. But I'm going to go ahead and keep my picture normal. So I'm looking for the adjacent. I know the opposites. There's my sides. This is the adjacent. This is the opposite. Looks like I'm using tangent again. So the tangent of 20 degrees equals opposite, 73, over adjacent. So I'm going to go through my calculations now. So let's see. The tangent of 20 degrees gives me 0.3640. So that's 0.3640 x equals 73. So 73 divided by my last answer, x equals 200.5659. And this time, we don't have to add anything to it because that is the horizontal distance. Again, they didn't tell me what to round to, so let's just round it to about 200.6 meters. Okay. Now, there's a difference of an angle of depression. Now, there is something neat about this, because if I take a look at how these two things relate to each other. So there's my type of lighthouse problem. Notice that the horizontal lines are always parallel. And the line I use to create my angle of depression or angle of elevation. So That's my depression. That's my elevation. Elevation. Notice that they create parallel lines cut by a transversal, make my alternate interior angles congruent. So that's a neat way to take a look at these. I could take that last problem we did, and now that I see that, maybe I don't like my triangle upside down like this. Maybe I want to draw my triangle right side up. So maybe I want to take this triangle and look at it this way. There's my right angle. If I do that, now this angle of depression I can put here at the alternate interior angle. And now I'm solving the same thing. Okay, so there's another way to look at these problems.
So here we are at my house and trying to do some of this and show you what this angle of elevation, angle of depression looks like. One of the best ways to look at it is, well, my cat. I know that sounds weird, but when we come outside to do some work outside, my cat likes to sit up in the window and see what's going on. So the cat looks down on my wife as she's on the ground here, and she's looking up at the cat. So let's take a look at what that happens, what that looks like when it happens. So looking up at the window here, you can see my cat Widget, just barely. You can see his little kitty head sitting there, looking out the window, and he's looking out the window at my wife standing on the ground over here. Now, Widget is 11 feet high in the window. We stand over back this way and scan out more. We can see Widget is 11 feet high, and my wife is standing away from the house. And we can get a measurement there. So let's take a look at what this looks like.
Okay, so let me get rid of this little picture there. So on this still shot, we can see some measurements here. Now let's start with Widget. Widget is, we said, my line, 11 feet in the air. So that measurement is going to be 11 feet. Okay, so we'll mark that as 11 feet. And now my wife, well, she's not 11 feet, of course. She's standing this distance away. And I measured that distance and found that to be 27.5 feet. Okay, now we do have to remember, because my wife, her eye is not at 27.5 feet. So when we match her eye up to looking at Widget, she's, whoops, that's not the button I need. There we go. Her eye looks up to Widget here. Okay, now my wife, for her height, where her eye is to the ground, well, that is 5 feet. So now we have an actual triangle that we can create here. There's our horizontal line. Remember that whenever we're doing angle of elevations, it's that horizontal line that makes the difference. So the angle of elevation is here. That's the angle that she's looking up to Widget. Okay, so we have to do a little bit of work there to get those measurements, but we can very easily figure that out. Now, let's take a look at this from the other direction, from Widget's view.
Now, Widget's view, his angle of depression is slightly different because he goes from looking straight ahead like this to looking downwards. But remember, that's not the angle of depression. Let's go back to here, looking straight out, and let's look at the outside picture and find his angle of depression.
So now we're going to calculate Widget's angle of depression. Okay, so first of all, think about where his angle of depression is. We said Widget is looking out of a horizontal line. If he looks straight out the window, he's looking that way. So we have to decide which of these angles is his angle of depression. I'm going to put two letters here. Is angle A or angle B his angle of depression? Answer that question. Okay, hopefully you said that it's angle A because it's from the horizontal down. It's not going to be, as a lot of people seem to believe, going that way. Okay, this is not a horizontal line. So because this line is not horizontal, we can't do a horizontal down. So your horizontal downwards, that's where we find our angle of depression. Now we can get our measurements. That's where things get even easier because we've already got a lot of that. We've already got, he's looking down this way here. And then we just need our third side of our triangle, which is right there. And now we're just a matter of getting our measurements set up. So we already know this distance across the top
is 27.5. That's the same distance as the bottom. Now, when we go to get this distance of this third side of the triangle, well, that we have to remember is the 11 feet, because what you've done here is you've created one giant rectangle. So that's the 11 feet minus the 5 feet from her eye. So that's going to give us a height of 6 feet. Okay? So now to calculate our angle A, what trig function are you going to use to calculate angle A? Okay, so you should have said I've got the opposite and the adjacent. So that makes me think I'm going to use tangent of angle A, which is the opposite, 6 feet, over the adjacent, 27.5 feet. But again, I'm looking for the angle, so that makes me realize I need to use the inverse to calculate this. And that's where I need to go to my calculator. So I'm going to go to my Desmos calculator. And before I do anything, I need to check on what of my calculator? Hopefully you said check that it's making in degrees. So I'm going to type in sine of 30. And I automatically realize that because it gave me this 0.9 thing, I'm not in degrees. So I need to change my settings. So I go to my wrench, change my settings to degrees, and now I'm good to go. Okay, let me go back and find my measurements. 6 over 27.5. So we're doing the sine inverse. So functions, sine and, nope, lies. Not sine inverse. We want cosine inverse, right? So let's get that and delete that. Or tangent inverse. That's what I want. Tangent inverse. And I put it in the wrong section. Tangent inverse. And the numbers are 6 over 27.5. So 6 over 27.5, enter. So it looks like Widget's angle of depression is about 12 degrees. So now that we calculated that, we can say Widget's angle of depression is about 12 degrees. Now, you should also be able to say Ellen's angle of elevation is also 12 degrees. Because remember, parallel lines cut by a transversal make the alternate interior angles congruent. So that's also a 12-degree angle. Okay? So what you're going to do tonight is you're going to work on 2 different quizzes problems, okay? There's 2 of them because one of them's just sort of information and one of them's going to be using this. And then you're ready to start some other information, okay? 2 things to remember though: angle of depression, down from a horizontal line; angle of elevation, up from a horizontal line. So make sure you get that idea right. That's downwards, that's upwards, both from a horizontal, okay? Try the next few problems on the Quizlet, and we'll be good to go. Have a nice night.